So next up, we have Vivek Saxena. He's joining us remotely today, but he is the founder and managing director of Advisory Aerospace OSC. Welcome, Vivek.
The aerospace industry, and that can be applied here for the AAM production. And postdoctoral work is in modeling and simulation. My company highlights are given here. I would like to point out that we are essentially about enabling factories to become smarter, to do more with less, more efficiently. And I'm a startup like most of the eVTOL companies. We recently won a SBIR award from the National Science Foundation to build Optimizer Aero, which is our branded name for an optimizer for complex operations. And the beauty of this is that this applies to any factory that may or may not have any data systems. So for more eVTOL, most of the eVTOL companies that are just coming up, it'll be a start for setting up any data system. So we can help you optimize your operations and whether or not you have a data system or not. Lessons from manufacturing operations, legacy aerospace. So there are lessons on the operations side, and then we'll go over lessons from the supply chain side. On the operations side, here's a fact in aerospace. Most aerospace factories with complex manufacturing show very poor KPIs. You know, the velocity throughput is not very good, on-time delivery is poor, and people who do say they have 98, 99% on-time delivery, it's because they're doing it with brute force, with highly inefficient method by having huge buffers for inventory and huge buffers for resources. So they're not very efficient. I can tell you from my experience working with scores of factories and also running factories myself, that is the case. And there are multiple reasons for it. But some of the big reasons are that, first of all, in manufacturing in general, only 13% of data is utilized currently to make some sense out of it. This is a survey done by IDC, and this is basically saying that any factory, about $250 million revenue, so this is your medium to large size factory, generates about 1 terabyte of data, and only 13% of that is utilized. In aerospace, it's actually worse. It's probably half. It's certainly in single digits that is utilized. On top of that, we have additional problem that all the data systems use various applications which may be disconnected. There are things that are happening offline. Very few people have a full view of what's going on in a factory. So disconnected data systems or multiple systems of collecting data with sometimes duplication and not a single source of truth, and then not utilizing the data for the benefit of running the factory more efficiently. Those are the things we know are happening in legacy aerospace system, which is highly inefficient. So something that the new AAM world can actually learn from and apply a technology to go beyond those problems. Now, that was operations and supply chain, similar issues. What is OEM supplier dynamics? It actually depends on the phase of the program. So you can see initially This graph shows until entry into service, there's development, then you have growth, then you have maturity, and then you have sunset for each program. So if you think about the eVTOL air taxi world, for example, we are very much in the pre-EIS phase, and a lot of focus is here. However, if we don't prepare for later phases of this product life cycle, we are doomed to repeat the problem we have faced in legacy aerospace. So, I mean, right now, we know there's all kinds of inefficiencies in the supply chain management in legacy aerospace. For example, let's think about your part visibility in the supply chain. The current two major approaches that OEMs or tier ones have for their sub-tiers is something that goes back 20, 25 years, which is the static supplier portal, highly inefficient, requires a lot of overhead on both ends. And then you have the so-called command centers, and I can tell you, having visited many of these command centers at legacy OEMs tier ones, even though they've been set up in the last 3, 4, 5 years, they are nowhere near exploiting the technology that is available to them. It's a fancy room with all kinds of screens with some additional visibility to certain things, but it's still not anywhere near where it can be. So given the problems I just described in legacy aerospace, as far as manufacturing operations are concerned and supply chain management is concerned, let's think about what we should be doing in advanced air mobility so we can meet the kind of volumes that are required to make the business case successful. By all means, it's going to be much larger volume, albeit the bill of material is going to be somewhat simpler than a big commercial or military aircraft. But the content, as far as hardware and software are concerned, is still very complex, and they will be multi-tiered supply chain. So what we are proposing is that we need to bring all the tools of Industry 4.0, or as we say, Operation Supply Chain Management 4.0, to bear. Some of the things that we've been doing recently with both legacy and new suppliers is full factory and supply chain visibility. There's no reason why an OEM cannot have a view into the data systems of their suppliers to the extent that they can see things that they're entitled to see anyway, rather than the highly frictionalized way of actually asking for information through emails or phone calls and so on. In fact, we're working on a project with Boeing where they have asked us to work with some of their smaller suppliers and get better visibility into their parts instead of making these phone calls and having very high overhead conversations and exchange of information. And it's a real-time information that they can get by a push of a button. And I think we should be thinking about that for advanced air mobility as well. Secondly, think about modeling and simulation of supply chain or modeling of simulation within a factory. These kind of things are very easy these days. You don't have to buy a very expensive software from a software vendor. Small startups like ours, we can do that. And we have done full simulation of a factory with a couple hundred people, about $500 million, $50 million type revenues in less than 2 months. And you can do a full simulation experiment on the shop, on the computer, and see what is the best way to organize your factory and flow the material. Optimization. Optimization is a word thrown around quite a bit, but true mathematical optimization is today possible. Algorithms which were developed in the 1990s are about 1 million times faster today. And using Moore's law, the computational power is another 1 million times faster today. So you can do those optimization problems 1 trillion times faster today than you could do 20, 25 years ago. And that power is available to you and run optimization problems of a complex factory or a complex supply chain on your laptop in a matter of seconds, if not minutes. So given all these technology available to you, this is what we can do. There's not enough time in the presentation to go over all the details, but I look forward to the Q&A session, and thank you for your time.
Perfect. So we have ample time here for some amazing questions. And I believe we do have Vivek online as well with us to be able to dive in if there's any for him specifically. But one thing I loved that Vivek just brought up in his presentation was this idea that if we don't learn from our history, we're going to repeat it, or we're doomed to repeat it, right? So I think that's kind of where I want to start the panel, if everyone's okay with that. Let's talk about lessons learned from the aerospace industry, their supply chains. What insight, what improvements do you recommend for new entrants such as AAM to do or consider? I know, Vivek, I'm happy to throw it to you first, since you had some great points on those that last slide of yours.
Hi, Anna, can you hear me?
Yes, we can hear you.
Oh, brilliant. Okay. So, having spent close to 25 years in legacy aerospace, I'm sure if you talk to industry personnel in general, and you look at how supply chain is reacting to demand fluctuations, how it's reacting to their in-house resource constraints, it's all done in a very, let's say, non-database manner. And if you look at AAM volumes and the kind of demand ramp up you're expected to see, it just makes sense to learn from that legacy experience of running individual factories and running a network of factories using data analytics, using modeling and simulation and so on. I don't have to go into details of all the inefficiencies, but if you look at big numbers, for commercial aerospace, for example, every year about, roughly pre-pandemic times, about $150 to $160 billion worth of aircrafts were produced annually, right? So this is the aircraft rolling out from factories, $150, $160 billion worth of commercial aircrafts. If you look at what's in the inventory, if you look at the turns at manufacturers at inventory turns, which is a measure of efficiency, you're looking at Boeing showing maybe 3 to 4 inventory turns. Airbus probably a little worse. You go to smaller suppliers, again, you see inventory turns of, I've worked with companies with 1, 2, 3. Compare that to any other industry, automotive and so on. You see that there's a huge, multiples of efficiency that can be put into place if you do things using more data and simulation and so on. So there is all this opportunity. Fortunately, we are also technically at a good place where computing power is not so expensive. And we have algorithms to do all of these things that have been tried and tested in smaller scale and can now be done at scale. So I hope that gives a sense of where I'm coming from and where we can learn, and happy to answer any specific questions if there are.
Great, thank you. Dana, take it away.
I think one historical thing we can learn or use and apply, and this is me essentially channeling Kevin Michaels from Aerodynamic Advisory, but when we look at tier 3 of the aerospace supply chain now, the OEMs had already been putting price pressure on tier 1, who was happy to pass it through down to tier 3. And by then you're dealing with companies you've probably never heard of. They're small, they're build to print operations. And they were told, hey, get ready for 60 aircraft a month. This is pre 737 MAX grounding and pre-COVID. So they went out and financed the tooling and the hiring that was necessary to meet that production for orders that never came. And it just points to the idea that one of the most important models we need is a model for exactly what scale we're going to go to. And reasonable minds can disagree about what the end of this looks like. Is it commuters? Is it 500,000 aircraft? Is it just a couple of use cases related to public safety where you're putting multi-copters on top of fire stations and maybe you only have demand for a couple of thousand a year? So I think one of the things that we need to be very careful with is what demand we use when we look at modeling the supply chain, because it's going to look different depending on what we think the end game is going to be. And there's a huge debate about what that is, all the way from the commuter case to the boutique rich people to the airport case, right? And those are very different demands in the supply chain. And the last thing we want to do is leave these potential suppliers out to dry by giving them estimates that are too high, that they tool up to meet, and then the orders never show up.
Do you want to take it away, Alan?
Sure. I'll stay on that same line of thinking for a moment. If we're looking at lessons learned, and there are lots of lessons learned, but if you're talking about tiers in the supply chain in particular, one of the problems that has existed in the legacy supply chains is over time, our larger manufacturers would learn about the downstream supply, go around a supplier, cut them out of the supply chain, and they lost the trust of the downstream supply. You find that manufacturers are very guarded about their information, very guarded about data, very guarded about what they're willing to do in that supply chain. And as part of the lessons learned, one of the things we learned is we were talking to some of the OEMs who were asking us if we could provide supply chain risk visibility down the tiers, because one of the things that traditionally we suffer from is a lack of visibility down the tiers of our supply. So if you look at it, most companies have an understanding, obviously, of their tier one, but they lose a significant amount of visibility the minute you move to tier two. By the time you get to tier three or beyond, there's limited, if no visibility of who those suppliers are, what they supply, or if there are any risks associated with the things that they are supplying. So in fact, one of the solutions that we roll out next month is the ability to show the downstream risk to an upstream supplier without divulging who the relationship is. And if we are learning from our lessons that we've been taught from the past, hopefully we're understanding that we have to protect each tier in the supply, particularly from a data perspective, if we really want to have a supply chain that is willing to stick with us through thick and thin, is willing to go through disruption, who's willing to be resilient in a time of downturn, because by causing that lack of trust in the supply chain, we've actually eroded our supply chain significantly, particularly here in the US. So that's one of the lessons learned. Another one is that we can absolutely protect the information as the manufacturers provide it to us, no matter the tier. And as we think about that going forward in AAM, we have a great opportunity to build a supply chain that allows us to see the risk, to see the demand, as it's flowing up and down the supply chain while protecting the relationships that exist.
So I'll jump in on something. So what you're all talking about is a vehicle that you actually know what you're even trying to build, and it's in a manufacturing facility that you control. The awesome responsibility of figuring out infrastructure is every single site is actually different and out of your control. From a number of different points. The only control you have is how many sites do you put into that funnel and begin the process of de-risking those sites. So I think that that's something that I want to talk a little different about other supply chains. So it's concrete, conduit, rebar, steel prices, copper volatility, a whole bunch of other things, and then labor supply shortages to go and construct these things. Those are relatively easy, I'm going to say, because that's the price, that's what it is today. The part of the supply chain and the infrastructure side that's a little more zany has to do with things like grid supply that takes 5-7 years for a utility to go through their integrated resource planning process in order to get money to build the feeder that you need in order to supply that location. And mind you, lessons learned, to be candid here, is if you're around an airport, by the way, there's a whole bunch of logistics companies that have little trucks and bigger trucks that are slurping up megawatts of capacity for their vehicles. So when aviation comes about and says, oh, I want a megawatt or 3 or 4 or 5, maybe 10, we get to big airframes, 10, 20, it's going to look like a data center on the airfield. You're going to be 5 years out before you can even hope to start to get the financing together from the utility that needs to bring that power. Now, Texas might be a little bit different. You've got a little bit different grid operators, a little bit more wild west of it all. Maybe in Europe, the distribution network operators might be different. But every single jurisdiction, all 3,000 utilities, are different in the United States. Everyone has a different model for their planning, capital acquisition, and ability to go build the assets that you as a end user load need to operate.
Dave, share your thoughts.
So I'll give it to you from an operator's perspective. We're at the other end of the supply chain as the consumer. With traditional helicopters, we buy aircraft from fundamentally 4 manufacturers, and they control the entire supply chain. So if I'm operating an aircraft in Nigeria or same aircraft in Australia, I've got to rely on a supply chain that's centered either in the United States or in Europe. They control this, so they have all their tiers that plug up into their production, and then they expand that supply chain out to as less than maybe the power plant. So that creates a tremendous amount of inefficiencies for us, and requires us to overcapitalize our structure. For those 240 helicopters that we have, and some aircraft, we have $110 million in inventory to support them at any given time. That's turning at a relatively rapid rate because we fly tens of thousands of hours a month. So what I like to see, and one of the things that excites me about advanced air mobility, are the volumes that are going to hopefully allow for a larger and a wider variety of supply chain. But most importantly, these aircraft that are being developed are going to have less moving parts. They're going to have less dynamic components. They're going to have less cooling and liquid heat and things that fail at a relatively rapid state, like gearboxes and servos and hydraulic components and things of that nature. So that's the big excitement here, because we have a cap on the supply side. Our supply is very expensive. Helicopters are extremely expensive to purchase, and so you got a big capex problem. And then on the operating side, they're also very expensive to operate. That's because one is inefficiencies in the supply chain, and two is they consume a lot of components. So if we can solve one of those problems here, then we can place together a very compelling business model and hopefully have a higher reliability product that we could support a global supply chain.
Awesome. Well, while you're still in the hot seat, I'm going to ask a question here from the audience. So they say, as we discuss supply chain, have OEMs or regulatory groups began discussing how the MRO aspect of these aircrafts may differ or be similar to today's aviation market? As an operator, is Bristow expecting a new variant of the A&P mechanic?
And that's a great question. Yes, the answer is yes. And I think 10 minutes was hard to present, but that's one of the value chains that we believe we fit into, developing supply and MRO systems that are necessary to support these vehicles. But also, as we progress with our partners in the OEM side, is we want to kind of avoid things that need an MRO. I heard somebody talk about it a little bit today, and frankly, we do most of our maintenance is done in the field. You do a progressive maintenance process. You do it online at night, so the aircraft's available for morning flights. That's the most efficient, cost-effective ways to do it. And do that, you have to build a robust aircraft that you can maintain without a D check or a 1,200-hour check or whatever that scheduled maintenance happens to be. And if we can consume that out in the field maintenance, then you have lower capital invested. You have higher reliability and higher availability of your assets, so you need less of them, and that's the objective here. But there will be things that need to be either disposed of or overhauled. So some of the motors, some of the blades, some of the other moving components that are coming around. But we hope that there's less requirement for MRO and more of just a consumer replace on unscheduled maintenance.
Great. So Paul, the next question is for you. How are you going to standardize the charging for different eVTOL type while the manufacturers still haven't finalized their charging methods or even have different plugs? By using Megawatt Station, would it shorten the battery life as well?
That's a whole bunch of things at once. What did you say? Yes. Yeah. So standardization brings a lot of things. One of the things that it brings is about investment certainty. What's coming down the pipe? So if you look at an organization, UPS, FedEx, Amazon, something like, you're going to be buying, tens of thousands of assets. When you get them all home at your depot, do you want them to be able to plug in or not? Do you want to be able to purchase them from General Motors, from Arrival, from Rivian, from Daimler, Tesla? And that was a loaded last one to say. you may want to go in a proprietary manner in order to keep moving. So standards can slow you down, but eventually in a mixed vendor OEM world, standards are going to be what you're going to rely on for interoperability testing. You're going to be looking for things that your customer can say, I can create a capital plan for XYZ number of years, and as I flip these switches for these depots or whatever the portion of that fleet transformation is, they can count on how they're going to make those investments. Megawatt charging, a lot of folks say, oh, it's never going to happen. 20 minutes for a semi truck to return to road. Just watch. It is coming to reality TV around on our roads. Does it hurt the batteries? Well, by the way, the batteries are 500 kilowatt. They're going to be megawatt hour type batteries. So you are actually dissipating and bringing that energy into a much larger battery. And these are getting designed for that kind of duty cycle. And you can count on that there will be some battery depletion, but that's going to be part of the overall model. And the TCO of these vehicles is going to pay back rather handsomely, rather quickly. So it's just part of the model. I'm also a big fan of V2G, vehicle to grid. That as you bring these assets out, you exercise the batteries even more beyond just their transportation needs, school buses and others, that you're putting hundreds of megawatts, gigawatts of batteries out there. Then absolutely with the grid, if you can earn a return on being flexible when you charge or discharge, then by all means put it into the model. And you're going to see more and more of that. And you're going to see resilience, a whole bunch of things come in around how do you actually keep these vehicles up and charging.
Awesome. I was hoping as a group we might tease out a little bit more of that standardization piece. And what are the perks to standardizing at this early of a stage, and how may that affect us in the long run when we're looking at supply chain and infrastructure? Start us off, Dana.
I work a lot with some of the suppliers of various components. Materials might be a good place to start. If you are a materials supplier, especially a large one, you see a lot of the landscape. You see the formulas, for lack of a better word, that the various OEMs are using to build their prototypes and are contemplating for their production aircraft. And the feedback I've gotten from them is, well, what their approach, their formula actually is, in reality, they're all pretty similar. And we, as a supplier, would much rather carry a smaller inventory of materials than to have this large inventory of things that are only very slightly different. And because the OEMs don't really talk to each other, they don't realize that they're working with very similar materials. And we would really like to sit down with them and propose a group of materials that we know, because we've seen what they're up to, that they'll all agree to be interested in. They don't have to tell us what they're doing. They just have to say, yes, this looks like it could work. So we can coalesce around half a dozen materials. And then, we as a manufacturer don't have to carry all these slightly different things in our catalog, and we can be more efficient and pass that cost savings on by getting the OEMs to come together and agree on a suite of materials. Now, I think there are a couple of efforts independently underway to do that, and I'm optimistic that one or more of them will either succeed or combine and succeed. But I think that's an example of the sort of standardization that even at this stage can help, just because these firms are very vertically integrated and quiet about what they're up to. But in reality, a lot of the demands that they have and the needs that they have are similar enough that we could probably start to move sort of toward a standard without them having to give away their secret recipe.
Can I chime in, Anna?
I see Vivek popped up. Would you like to jump in?
Yeah, sure. Just a quick one here. And I think just sort of echoing and further to expand on what Dana just said. We made an estimate about a couple of months ago. I published an article in Aviation Week. And our estimate was for MRO supply chain to adopt technology. One of the biggest drivers is just the way manpower is being used today. Our estimate is that up to 2% of total employees in aerospace sector, it's a startling fact, 2% of aerospace employees in aerospace industry are just there to report. They're not adding value, they're not inventing things, they're not helping the customer, they're just reporting. Why is that? Because everybody has a different system. If you are even simplest case, if you are providing an engine part to 3 manufacturers, Rolls-Royce, GE, and Pratt, everybody has different requirements. They have their supplier portals. So to bring about a real tangible reason why you need standardization, you can think about if you can reduce that overhead, that effort, 2% of the people in a company just doing reporting and in a larger sense, industry-wide. Standardizing is a great thing. And actually some good steps have been occurring recently. And I want to point out IAQG, International Aerospace Quality Group, that has come up with some standardized requirements so that when build-to-print manufacturers are reporting on quality requirements or certain quality procedure-related items, it has now been standardized. So for different OEMs or different tier ones, you don't have to provide different format or different type of information. So IAQG effort is something which can be a beacon to how AAM standardization is done, which is more practical and is reducing the overhead on the part of suppliers.
Take it away, Dave.
So again, back to the operator space, but I will tell you, I worked in manufacturing. I was with Sikorsky for 20 years, so I get both sides of the coin. When I hear standardization, I think safety, and then efficiencies and cost follow, and sometimes maybe not, but most importantly, safety. So think about the amount of volume we're going to have, and one of our chief engineers said it. So I hope I don't offend anybody. We're building these beautiful, elegant machines, and then we're going to give them to gorillas, and they will find a way to break them. And if we don't have a standard charging station, we don't have a standard charging plug, we don't have standard tools and equipment, standard ways to do that, then we're going to hurt people. And with those standards and to come the efficiencies, needing less material, needing less tools, that's a great byproduct, and hopefully cost follows with that. But most importantly, we have a chance here, and we have a relatively clean sheet of paper to do it, and there's no reason why we shouldn't. And again, that's part of what we hope we can bring to this, just that thought process about it. It's not just about having an efficient supply chain; it's about safe ground and air operations.
Thank you. Take it away, Alan.
Yeah, I'll just add one thing, because first off, I echo everything that's been said, and standards, I think, are a key to efficiency, to safety, to so many different aspects of having a quality ecosystem. One of the cautions that we should think about as we move forward is, what is our time frame for updating standards? I'll just give a quick example, NAICS codes. For those of you who have ever worked with them, then you know exactly what I'm talking about. We don't have the processes in place for updating the standards in a timely way that allows us to evolve as an industry. So in AAM in particular, since we have the ability to really start from scratch, we should think about it in those terms, accomplishing all the things that standards accomplish, but also ensuring that we have processes in place to allow us to evolve at the pace we need to evolve.
Just to add, and we should not ever throw out what we already have available that we can leverage. So we're dealing with a lot of scenarios that have fueling with potentially hydrogen, other hydrocarbons, and electric. And we're going to be putting these on the exact same, airfields, call it, or building tops, or, a whole variety of things. So NEC code for National Electric, what's going on in the States, what's going on in Europe and other parts of the world. How do we find some of those things that are today truly global, that pulls together what is already on the books, and some of it might need to be thrown out a little bit or rewritten, but not lose speed on that. This goes back to EuroK and some of the groups that are trying to work diligently, SAE working very diligently to say, hey, look, what do we have that's already on the books for, the accessory air frames being charged or being brought energy out to them while they're there parked at the gate? Aren't there enough other standards already in place that you can start to leverage those things? So that's the call out on my slides. If you go to those links, participate. And I've been on a megawatt charging standard for trucks since the early part of 2018.
Wow.
And it's been a very private NDA covered activity. And in the last month, it's now very public and part of SAE. So jump in. This is the time.
Go for it, Dana.
If I could just ask or add one last comment on standards, you know, one of the things that keeps a lot of people probably in this room, including myself, up at night is the talent pool, right? We already have a shortage of pilots and maintainers and engineers. And, you know, how are we going to replace them? You know, I dropped my son off at Embry-Riddle last fall, and I looked around at the kids coming in there, and I was like, if you only knew the demand that was going to be facing you guys when you came out of school. Standards apply there too, right? I mean, if we're going to keep enough of these people trained, do we really want to train them on 6 different platforms? That's horrifically inefficient. We're going to need to standardize for the sake of manpower. I mean, just for training purposes, this is going to make things way more efficient and address this huge elephant in the room of human capital and who's going to maintain and fly and engineer these things. So standards are hugely important for that too.
Oh yeah, absolutely. Yeah.
That's it. I think Dave touched a little bit on that in his presentation when he talked about how many hours we're going to need to get these people to log and really be prepped for when AAM comes. That's huge.
Yep.
So the next question is for Alan. You briefly mentioned the stress placed on our small to mid-sized manufacturers because of the varied supply chain database solutions. How can we overcome this obstacle?
Yeah, it's a great question. And, you know, in our country, we pride ourselves on competition and making sure that we have all kinds of open competition that occurs. And occasionally that gets in our way for having the right solution. And so in this case, we need a solution that we coalesce around as an industry. And we need to be able to lean in on a solution that allows us to be able to take a little pressure off of those small, medium-sized manufacturers, that allows us to have them record data in, you know, 1 or 2 places instead of, you know, 15, 20, 30 places. And we'll find that the inefficiencies that we find in the data that's being provided will go down significantly, because when there's a person responsible for doing that at an organization, if they're responsible for updating 10 or 15 different databases, I can guarantee you those 10 or 15, if they're responsible for updating 1 or 2 sources, there's a higher probability that that information will be kept up to date. So we can definitely make it easier on them by leaning into some, if you will, standardized solutions that allow us to be able to see those capabilities, allow us to be able to exchange that information and not require them to have to enter it in for every single organization that wants to gather data. So I'll share one quick example that might be relevant. Lockheed Martin, I don't know if there's anyone from Lockheed here today, but they pride themselves on having one of the best databases of manufacturing data in the United States. They require every manufacturer to put their data into their database. Well, Northrop and Boeing and go down the whole list of OEMs all also want the manufacturers to add the data in. So if they're providing to multiple OEMs, they're having to update all of those databases. And oh, by the way, if they're doing any government work, they're having to update the data in numerous government databases. So I give that as an example because it's a real problem that we have today. And it is a real pressure that we put upon our small, medium-sized manufacturers, and we can do it differently going forward.
Lockheed doesn't trust that the data was collected from Boeing, that it's valid. Like, how can we kind of break through that?
Yeah, and part of that comes down to each of them having their own process for vetting a manufacturer and a manufacturer's capabilities and certifications. So the more we standardize on those certifications, and a standard will meet the qualifications or requirements for all of the OEMs, the more we can actually simplify that process, and the easier we make it upon our entire industry.
Dave, from an OEM's perspective, do you encounter this a lot in your business or different pieces there?
Yes, because some of this resonate with me, but on a different. You know, we kind of are a small supplier to the energy business. And we're our market cap is $1 billion, and we support BP, Shell, and Exxon. There are hundreds of billions of dollars. So we're that small supplier, and as suppliers, we are audited by our customers. Last total, I think, is about 250 audits a year. So we have huge teams, much as I had mentioned, that just support answering questions to aviation advisors and other safety advisors around the world. And I have a bit of a cynical think about what this is. So I guess it's the same thing with Lockheed and Boeing. It's also job security for some people. They have a role and they have to do it a certain way. Some of it's liability, but a lot of it gets down to they've created these environments. Some because the suppliers failed. They fail in their quality control systems, but some just because of the situation. So if there's a way, we've been struggling with how to really standardize aviation audits, and we've never been able to. Actually, we've just seen it getting worse in terms of how much oversight we have. And it's not from the regulators; it's just from the pseudo regulators.
So my next question is for Dana. Are the assumptions for pricing of aircraft, dollars per mile, dollars per seat, et cetera, how much are these models driven by enormous market assumptions and therefore contain significant amounts of risk for suppliers?
Yes. Well, I mean, it depends on the use case, right? I think there are some that are easier to wrap our heads around. There are some that are more likely to be subsidized to a degree by state and local governments, things related to first response and other things that are perceived as public goods. Everybody's got surveys and everybody's got a use case that they're touting as being the sort of the one that they're going after, right? And we'll see a lot of those during the course of this conference, and they're by and large well thought out. The real question, though, is, what details in these models are we missing? And I'll say, in just the one that it's been my pet case for the last couple of months, is I've been talking to AIG and Allianz and Berkshire Hathaway and saying, okay, you guys are traditional aerospace insurers, talking to the underwriters here. What are the rates going to be for these things? And are you thinking about this? Their answer is yes, we're thinking about it. There's no actuarial operational history for these. So we're going to be conservative, which is code for expensive. And they also, how many hours are they going to fly? What's the format of the aircraft? And I mean, we've got this huge diversity of aircraft types, some of which, there may be commercially viable multicopters that behave very differently from a safety standpoint in the systems that are necessary than something with a wing, right? And so they're thinking about this. And the question that I asked them as a follow-up is, have the OEMs been calling you asking about this? And pretty much the answer is no. And that was the most telling thing, right? Because it's going to be a potentially very, very significant operational expense. And it doesn't seem like most of the OEMs have at least been calling the people I talk to. I mean, they may have people in-house who've been dealing with it. For all I know, maybe they hired some people away from some of these companies to do it for them. But I haven't heard them mention it too much, and I haven't heard from the underwriters that they've been called on it. And if you look at, hull loss and liability insurance in the well-known 50-year operational history for commercial aircraft, I mean, you're still talking about 2 to 4% of hull or airframe hull loss insurance, value of the entire airframe per year. Helicopters, it's probably more.
Right.
Yeah, and then that's not even counting the liability side of things, which is going to be significantly larger.
Yeah.
So when we talk about operational expense in the $2 to $3 per seat mile, I'm not going to throw a number out there, but I'll tell you that the numbers could be high enough to really throw the economics behind these operations into a tailspin until there's enough data gathered on them that the actuaries start to feel more comfortable with bringing those premiums down.
I could talk a little bit about insurance if you like.
Go for it.
Yeah, so I think that's one of the interesting attributes. We have engaged with our underwriters. It's a big cost for our business. As mentioned, the hull liabilities are quite high, and whether the values, that's one of the big unknowns here is the value of these hulls and the residual value of these hulls and how long its lifespan is. But when you get into the liability side, We have to carry a tremendous amount of liability because of the nature of our operations, either rescuing people or are flying out to drilling ships that are $600 million and the production that's associated with it. So insurance is a big part. So that's why having, as we start this process with operationalization, working with sophisticated operators who have the trust and understanding of the underwriters will benefit the whole ecosystem. And then as public perception gains, because bad things are going to happen. The math is there. Even at 10 to minus ninth in the safety by design. We also have to have safety in operations, but we're going to hit birds, we're going to get struck by lightning, we're going to fly over radiated fields, and things are going to happen, and we're going to be in populated areas. So insurance companies are going to take a very conservative approach.
One thing I will say, feedback I've gotten from the underwriters is that VTOL operators who have existing business relationships with those insurers are going to experience significant, I guess, tailwind, or there's going to be already a sort of element of trust because they're teamed with an experienced operator. So if you're an eVTOL and you're affiliated with one of these big legacy carriers or OEMs or operators, that business relationship is going to lead to probably some lower premiums than you would get if you just came out of thin air.
Completely agree. And sadly, in the insurance business, some of it is not our fault. Some of it is just the massive amount of destruction that's happened recently with the natural disasters. That all plays into their tables and affects our rates. We had a 20% increase in insurance rates last year.
Wow.
No accidents, no incidents, no injuries.
So everyone, we are at about 5 minutes left. So I'd love to give an opportunity for everyone to have just some last words, last piece of wisdom you want to share on the group here. Vivek, I'm going to have you start us off with just anything you want to share before we close out.
Just to add, I'll take 30 seconds to talk about the insurance issues because I used to run a general aviation OEM, and insurance is always a significant piece of cost of ownership, etc. But I think if you look at the Pareto of operational cost, we don't want to overplay the insurance issue. It's certainly something which needs to be considered, and there hasn't been significant amount of discussion in the industry. If you look at the Uber Elevate white paper going back, one of the first major documents to come out for AAM, there isn't too much in there, and people don't talk about it. So I'm glad that Dana and Bristow are talking about it, but it's not a showstopper. I think if you look at the overall cost structure for operations, it's not going to make a whole lot of difference. So let's, we have to look at the way safety is designed into the aircraft, and can you prove it before field operations and build the actuarial history as you start operating it. There is going to be significant amount of conservatism from the underwriters, but in the long run, I don't think it's going to be the driving cost for operations, but must be considered. In terms of reporting, I think we heard from various people, both in the OEM supply chain as well as MRO supply chain, this whole thing about having hundreds and thousands of people in the industry engaged in reporting things which are non-value add. It's certainly something we can work through technology, but here is a caveat. There are technology solutions, but they have to be affordable, because the bulk of manufacturers are small and medium-sized manufacturers. For example, in legacy aerospace, you may have 3 or 4 OEMs, but you have close to 6,500 aerospace manufacturing shops in the US alone. So when you're thinking about a standardized solution and you're thinking about something that uniformizes and makes things more efficient, they have to be affordable for the SMEs. So let's not forget about the affordability of technology solutions, and I think that would be my last thought. Thank you.
Perfect. Paul, take it away.
Well, I'll just try something. How many utilities are in the room? Raise your hand. Electric utilities? That's your supply chain for your new energy fuel. Does that concern anyone?
Yeah. Maybe they're in the next row.
Just I love to do that. Sorry. This is about de-risking,
Yeah.
right? So, how many urban planners are here today? All right, same. Long lead time supply chains to your success of deploying infrastructure. We need to talk to these people. We need to talk to people who understand how to talk to people. And then you got to go talk to the people who can talk to the expediters, to talk to those people, like in New York City, which is always fun to build. I would just encourage that. Look deeper into what are the other tentacles of what you need in order to be successful. I spoke in front of an EPRI, Electric Power Research Institute crowd 5 years ago about electric aviation. I said, could I talk about this topic? And they all looked and turned around in the room and laughed at me. You know what? They're going to love to sell you kilowatt hours. So make friends and figure out what is their governance and perspective? What's their business model? How do they monetize their assets? Behind the meter, in front of the meter? Learn a little bit about it. And if you need somebody to talk to, clearly that's what we do.
And I'll just build on that, Paul, because, as I think about evolving a new industry, this is an exciting time, honestly. If we think about it, these are great problems to be solving. And what a great, unique group to be solving them with. And so I'll just leave that as well as collaboration is a key to success, and it could never be more true than it is in an evolving industry like this one. And so continuing to work together, to collaborate, to make sure that we're working together to solve the problems will ensure the success and ensure the fact that we actually overcome some of these challenges that we still face.
Great.
Take it away.
Oh, I don't know how to end it better than that. So, yeah, just kind of collaboration, exciting time, lots of problems to solve, but the teams are out here to solve it. I just feel blessed to be able to be part of it in my career.
Augustina, you have the pressure going last.
Well, I think a lot of times data becomes one of the major points of emphasis here. And, Agility Prime and the Air Force and NASA, I mean, we're all working hard to gather data to give to FAA. I think, I'm not going to make policy here, but I think it might make sense to at some point start sharing some of this data in coordination with the OEMs, with insurance companies, right? With other people who have stakes in the success of this. I mean, yes, FAA, but sure, there are others who are craving data so they can do things to model how the operations of these things are going to work. And so we stand, ready. We are, currently gathering data on a number of different platforms, and, working with the OEMs are going to share as much of it as far and wide as we possibly can, not just to increase the timeline, but to decrease the cost and to increase the safety of these things. Because, as of now, they're not all that well understood, but it's well within our grasp to understand them. It's just more a matter of when the resources are there. It really is from a technical standpoint, it's something we can do. It's really more about how are they going to operate out in the wild, and how are they going to interact with customers, and that's the part that most excites me. And I echo your sentiments. It's an honor to spend my career thinking about this and being alive at a time when we're at this potential inflection point in aerospace. It's really amazing. So thank you.
Well, thank all of you. I'll be honest, I learned a lot today. But if all of you will join me in giving them a big round of applause. And I believe we're going on break, right, Carl? Okay, so you have a break till 3:30.